Okay, so from there, we're going to start with, of course, Treaty 6. So we just want to acknowledge that we're on Treaty 6 territory, which is the traditional meeting grounds for the Cree, Saulteaux, Blackfoot, Métis, Dene, Nakota Sioux, and that they've been taking care of this land for generations, and we are just borrowing it. And through all of the work that we do on our education, we hope to find that there is balance and equality and to restore what has been taken away from that people. So with that, then let's go ahead and get started. Our objectives today, I'm going to give a couple slides to just talk a little bit about programming. And then I do want to talk a little bit about some activities that you can do. While I was poring over the elementary curriculum over the past week or so, one of the things I really noticed was that the visual coding doesn't start till grade 5 or 6. So some of the activities that I will suggest are more for that grade level. That being said, I did a similar session about 4 years ago about the NDP curriculum, in which they started coding at grade 2. So I personally threw code.org at my grade 1-year-old last week, and she was fine with it. So what I want to say is that while curriculum-wise, it doesn't really start till grade 5, I think the sooner you introduce it, the better. But also that many students, like I was talking to a bunch of you, many students are already experimenting with it at a younger age. So even having a little bit of background is not necessarily a bad thing. So we're going to try to create an animation with Scratch today. What we're going to do is we're going to be using our name to get some pieces to move and kind of see how different pieces work in the Scratch environment. And then after that, depending on how long that takes, we'll either try something a little bit more complicated, or depending if it's only about 10 minutes left, maybe just time for you to experiment and take a look at what's going on. So the first thing that I want to say is first VoIP, okay? And this is the dumb thing that I have to mention. I will say if you're from Edmonton Public, that Scratch is already an application that has been gone through the third-party application process. You don't have to submit an application for it. You just need to put in school zone or whatever notification you use to tell parents that students are using it, only if you're asking them to create an account. If you do not ask them to create an account, you do not need to notify, right? Because it is not taking any information. For the teachers from other divisions, you just got to check with your own division on what is allowed and what is not allowed. But I just want to start with that to say that if you are interested in using it, just make sure that the proper steps are being used. I would say since it is already approved, that if it is something that you plan on using long term, it doesn't hurt to actually get them all to do their, to create an account, just because of the fact that then they can save their projects for multiple days, okay? Okay, from there, then I just want to start with an animation. And this in my next session is something that I'm going to actually recommend for a grade 5 activity. And when it comes to an animation, the reason is because it is something that uses a lot of step-by-step instructions without overly complicated branching of different options that can happen. So when I say an animation, they're basically making a video of some sort with the tools of Scratch. So that will be something similar to what we'll try. We probably won't do anything this intense for today, but at least we'll kind of have an idea of what we're going to be doing as something students can do if they had more time. The other thing is that, so this is kind of what it looks like when it comes to what block coding is. And to get us started with the idea of programming, I want to first say that I want all of you to first give yourself a little bit of credit. The one thing that I've learned from many elementary teachers is that you all are super organized, right? You have your stations, you have your calendars, you have everything set up in a very structured way, which when we think about computational thinking is to be able to perform an outcome through a series of clear, concise instructions that generally have a start time and an end time, right? Which is basically every single activity you do with your students. You're already programmers. Okay. So when we talk about, that skill you already have, what the block code is how do we represent that into something that is easily manageable? And from there, I would say that you can almost think of it as linking cubes, right? That you can attach one thing to another, and every single linking cube has its own action or thing that happens. So when it comes to just some of the things that we see on this slide, what we just see is that we have different puzzle pieces connecting together, and each puzzle piece does an action. Okay? That's really the idea of block coding, is that you have your puzzle pieces. This puzzle piece says move, this puzzle piece says turn, this puzzle piece says to say something, and you're just putting all of these instructions together step by step. The way that we generally describe it is as if you're trying to bake a cake, if you're trying to cook a meal, right? You have a series of instructions that you will be following, and that series of instructions is your program to make that cake, right? So when we think about programming, it's something that I want to reiterate that all of you already have the capacity and already a lot of the skills to be able to teach programming because of all of the wonderful work you already do. So that's the first thing that I want to say for this particular slide. And then from there, what I would say is that as you progress to more and more complex programming, it's kind of like the same thing as progressing to more and more complex recipes. It just means that you can have a bunch of different larger amounts of block code strings in order to get your particular program to do something. But this is like cooking Thanksgiving dinner, right? You got a lot of things on the go, right? But at the end of the day, they all have to finish up, and then you have your wonderful meal you get to share, and then everyone can food coma afterwards. Okay. So this is the only little bit of theory I'm going to give right now, just because it will help kind of structure what programming is all about. And what programming is all about is the idea of these three main concepts, which is that when we talk about writing a program, that the commands have to be sequential, so step by step. Normally, we can also think about this in the scientific inquiry unit, where we are looking for our objective, our hypothesis, our procedure, right? And then what are our observations and conclusions? So a step-by-step sequence. This iterative just means that things are repeatable, right? So that we can have either sections of the code that can repeat, so that if I was trying to walk towards the door, I'm not going to be like move, 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 move. I can just be either for 30 steps, move, or I can say something like until I hit the door, move, right? So being able to just repeat things so that I'm not just move, 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 move all the way to the end. And then finally, selective. Selective is the more complicated one, and selective is the one that comes into the curriculum officially in grade 6. I would actually say that programming is extremely limited if you don't have selective, because this just says true or false, right? So if it's true, do one thing. If it's false, do another thing. You can't really do a lot without an if-else statement, which is why grade 5, I would recommend creating an animation, because you don't actually need any, well, did they hit the W key? Did they hit the A key to move kind of idea? So that's kind of why there's that distinction. And I'll be honest, though, that the curriculum says officially 5 or 6. The curriculum being as flexible as it is, some of you have already mentioned that you're already starting to introduce it earlier. I personally think it's totally fine to introduce coding earlier if you're more comfortable with it, because of the fact that I don't, my personal belief is that you don't need to wait till they're 10 or 11 to start teaching them how to code, okay? Okay, so with all that preamble out of the way, then this particular slide that is in the slide deck is here so that you have links to the examples. So some of these examples that I'm going to show, I guess the first one is this name animation. This is the one we're going to try to do together. So just to be able to show that this is kind of what it looks like when the program is finished. So this is our sample animation for today. And then the goal is that we're going to have some letters float together and make a name. Hopefully your name isn't like 10 letters long. A short name would work. And then you have kind of this animation that you can use. The other things to kind of give you some ideas is already in the slide deck, you saw the scratch animation, which is something that I whipped up a couple of days ago when I was also figuring out how to use Scratch, because in high school we don't teach with Scratch, we teach with text programming languages. So instead of visual blocks, they actually write lines of code in which if they don't have the right number of spaces, it doesn't work. If they forget a semicolon, it doesn't work, right? All these things that make it that it doesn't work, that is more complex, not because of the computational thinking part, but just the typing part. So that's really the difference between the text-based and the block-based, is that your students don't have to worry about typing things correctly, right? They just need to worry about thinking. So this particular animation is one that you can also reference. And also the value of all of these links is if ever you want to see how they're made, there's the see inside, right? So you go in and you're like, okay, that's what Mike did, okay? And then you can even use that to tinker with if you wanted to change things, right? You can try and see how that all works. So that's why I want to include this. The other program we'll do, if we have enough time, is going to be this addition problem, which is just another way of using a few of the block tools. So you could have it where Scratch the Cat asks a question, and then you can type in an answer, and then Scratch will say something, or something right, or like something wrong. Okay, so that would be the next thing. And one of you was saying that it would be cool to be able to incorporate some of this into your class. So one of the other things that I have here as a sample is that you can also do this where you have a practice set. So in this particular example that I have for you, it also asks questions, but then it will also keep track of how many you get right or wrong, so that after they do 10 of them, they'll either say, yay, you did really well, or maybe try it again. And once again, you can always go in and see what is the actual instructions for it. And when you compare this set of instructions with the other one, this one looks more scary, right? And that's totally fine, right? This is not something I'd recommend you dive into right away, right? But trying to make the other one, which is only about 10 lines, is something that I think is much more reasonable to at least just start getting started. And then the final one for those super high achievers is the one that I did when I was refamiliarizing myself with Scratch, where you actually can move and collect apples. And then you can like move to a new screen, and then there'll be even more apples for him to collect. Okay, so that's to give you kind of the, like, if my students had 2 weeks and they were doing this for an hour every single day, you know, who knows what they could create. And once again, these are things where there is significantly more sections of code to worry about. But once again, this is where I say this is probably far beyond what you would ever really need to do in a class, but just so you have an idea of the capabilities of where it can go. Okay, so coming back to this name animator one, so this is the one that we're going to try to make for today. And for us to do that, we want to make sure that we are connected to Scratch's main page. So this is most likely where many of you are at. So this is where you can go back to your screen, and at the top of your screen, navigation-wise, you'll see the Scratch logo, and then you'll have this Create button. You can go ahead and hit this Create button. This Create button will take you to the editor. You can choose to create an account. I'd say save that for another day. But just to kind of give you a little bit of navigation for your project, is that on the left side, this toolbar is like your library of blocks. These are all of the commands that you can use. They're all color-coded. This center part, this white space in the center, this is the coding area. So this is the editor part. And then the top right corner where we see Scratch the Cat, this is what is going to get played. So when we actually run something, that's what's going to be visible. And then the bottom right section, this is where we keep track of all of the different actors, is what we generally call the items that are on the screen. The other word you could use for is sprite. So actors, sprite, either one can be used to say who or what Scratch the Cat is. Now, to get things started, the most simplest thing we can do is that we can just get Scratch the Cat to move. So then in the motion section of the code, there's a bunch of things that we can do. One of the things is that we can just move. So how we would start our program is that we can just click that move and drag it to the editor section of Scratch. Right? So from there, then, if we click on this particular item, it will move Scratch 10 spaces. Okay. This isn't necessarily us creating a program yet, and the reason why is this is just to be able to test what in the world is doing. So if a student doesn't know exactly what go to random position is, then they can pull it out and click on it to see what it actually does. Okay. If they don't want to use it, if it's not connected to anything, it can just float there. It'll just hover indefinitely. But then if you want to delete one of these blocks, so let's say we can delete this go to random position, we can just go ahead and drag it back to the code block section, and then it'll disappear, and then it's gone. Okay? So that's for us to get started. Also for us to get started is that we can click and drag any of our actors in the viewer section to where we want Scratch to be. And when it comes to our program, we definitely want it to be something where Scratch starts at the same position every single time. So that's the first thing that we want to do. Say, hey, Scratch, how do we get you to start the same position? So then at the top of our viewer, I want to just draw your attention, whether it's on my screen or yours, to the green flag at the top and the red stop sign. So this is how we tell our program to start and stop, but we have to also teach the program what to do when it actually starts the program. So this is where I'm going to click on the orangey yellow events section. And this section has a lot of complicated things. The only one that you're probably going to use to get started with is just the one that says when the green flag is clicked. Right, the very top one, when the green flag is clicked, that means that whenever they click that green flag, whatever is the blocks connected to this, that's what's going to happen. So if I want Scratch to start, say for example, if I want Scratch to start a little bit on the left side. Okay? So if you can please click and drag Scratch to the left side a little bit. And what I want to show, this is something that you can just see on my screen momentarily, is that I want to draw your attention to some of these x, y coordinates. I'm sorry, I don't know where positions are in the math curriculum in elementary. I know it's in grade 7 in junior high. But what I just want you to pay attention to this go to x and y on my screen. As I drag around Scratch, you're going to see that those numbers update. Okay? So why that's valuable is because as your kids are starting, it's okay, I want Scratch to start here. Then, okay, the first thing then is now that you've moved Scratch to where you want Scratch to start, then I want to go ahead and say go to this x and y position at the very beginning. Right? So this is so that if I end up, so once you've put that block there, if you end up moving Scratch, you're going to notice the one that is connected to the when green flag is clicked doesn't change. Only the one in the tool does. So that means that now, if I'm okay, I need Scratch to go back to where I set it to. Well, now I can click on that green flag. So you can go ahead, click on your green flag. Scratch will now move back to that position. Okay? So that's how you can get started with, okay, let's get all of our items where I want them to go. And then from there, now, maybe I want Scratch to be able to do something. Maybe I want Scratch to actually do the moving. So that is going to be my next thing, where maybe I'll get Scratch to move 10 steps so that I can put that to the next. Right? Then maybe I'll get Scratch to move to rotate, I don't know, 90 degrees. And then I'll get Scratch to move another 10 steps. So once you actually hit the green flag, it's kind of hard to see because of the fact that like he starts here and then he immediately moves, rotates and moves. We don't really get those like nice starting points where we can see it glide to a place or to another place, right? But this is like if I did want it to move a little bit, that's fine. But what I can do then is that I can get it to glide. We're going to get there in just a minute. But the thing that I wanted to point out with is that from here, we can actually now like see that by just putting blocks together, we are doing things to Scratch. He's basically just rotating in place. That 10 steps was just to make sure that I didn't like slowly start drifting, in case you were wondering. Okay, so that's pretty simple for us to get started with. How are we feeling? Is this, okay, we got our starting flag, and now we're going to start adding instructions to each of them. Okay, so hopefully we're feeling okay. Does anyone need me to slow down? No? Does anyone need me to speed up? No. Okay. Okay, we're going to be done with our Scratch the Cat. We're going to now start worrying about getting our name sorted out. So for us to get our name sorted out, so at the bottom right, where we have all of our sprites, so this is where you'll see Scratch just has a trash can on top of Scratch. I'm just going to click that trash can. Scratch is going to go away and our code is going to go away too. What happened? The rhetorical question is that whatever code blocks we do is linked to a particular actor, to a particular sprite. So if we have multiple sprites, they all have their own editing section for what you want that sprite to do. Okay. So now we want to go ahead and add some sprites that are letters. So in this bottom right where there's this cat plus, this is where we can click to start adding some additional items. You can actually upload your own pictures too. For time's sake, we're just going to use what's here. And from here, you can see there's a bunch of different things that you can use. I'm going to go ahead and switch to the letters section. And then I'm going to start with my first letter of my first name, so M. You can start with yours. And if you click it, then that's going to be what appears onto the editor screen. So then, once again, I can move this around, but I want to also just get all of the other letters. So I'm going to go ahead and just get an I. You can get the next letter of yours. So once again, clicking on the cat icon. So sorry, I did that a little quick. The cat icon, and then to the letter section, and then you can choose your next letter. And then just do that again and again for all of the letters you want on your screen. Okay, I'm just going to be a little bit more obvious with this one. Just give me a quick thumbs up if you're ready to go on to the next step. Thumbs up, thumbs up. Okay, good. Let's keep going. Okay, so what we want to do here is I want to first draw your attention. So looking up on my screen, and this is something that you're hopefully noticing, is that I'm trying to be really clear with when to look at your screen, when to look at my screen, because the kids will just ignore you if you don't tell them. So on my screen in the editing area, you're going to notice that there's now this like grayed out K here, right? So if you look back on your screen, you'll see that there's a grayed out letter on your screen. That letter corresponds to, looking back at my screen, the fact that the sprite is currently selected in the sprite area. Okay, so that's just how you can visually see where your sprites are. So then what I'd like for you to do is first put your letters where you want them to start in the animation. So many of you put them like where you want them to end. So where do you want them to start? That's kind of where you want them to begin with. And once you have it from where you want it to start, I'm just going to go ahead and show the instructions back on the screen. So just pause what you're doing, look on the screen for just a moment. I'm going to start with my M, so I need to select my M. So this is where I'm going to say for my event, when the green is clicked, then I want to go to this position to start. So I do that for my first letter. I then go to my next letter, do it again, my next letter, do it again, next letter, do it again. Go ahead and do that now. Yeah, well, you need one for each letter. One for each letter, right? So you gotta repeat that for each letter. Okay, so I'm just gonna go on in about a minute. The next step will be getting all of the letters into the position that you want them to be in. So if you want, you can start doing that right now as well. Okay, so the next step is that I now want to get my letters to glide. So just hands off your keyboard, eyes forward, so I can give you this next set of instructions. So now that I have their starting point set, excuse me, this is where I want to now move all of my letters to where I want them to end. So I have my endpoint, and now what I want to do is there is another one that says glide in 1 second to that particular position. So if I do that for just the M right now, so don't do it yet, just watch my screen. If I click on this and put it as my next one, when I go ahead and hit my green go, right, that one will glide to where it wants to go. And I can choose how long it takes. For our example, I set it to 2 seconds so that it will take 2 seconds to glide to that location. So once I do that for the one, now I can go ahead and do that for all of the other ones. So then I can click on my eye and say glide to this current position in 2 seconds. Okay, so now you can do that for all of your letters. Okay, I put you in the super wrong spot. Oh, random position.
Is there a way to make two things happen side by side?
Yes.
At the same time, like rotate as it glides, for example?
Yep. You would then put a second green flag and a second code block.
They both work together.
Yep, they'll work together. Okay? Okay. Hopefully also you're getting into the habit of once you've finished, then you can hit the green flag to see that it's working. And then in about a minute, we'll go on to the next set of instructions. Okay. So as our teacher at the front has mentioned, is like how do we get to do multiple things at once? This is where we get to the grade 2 section of having parts repeat themselves, but also the fact that we get to that structural programming section of iteration. So this is formally taught as a concept in grade 2, which is strange, but it is something that we can incorporate into the looping of getting our letters to go to kind of like wiggle as it gets to its position. So as our educator at the front mentioned, if we want to do two things at once, so I'm going to once again just do this for my M for demonstration, is I can just start with another starting block of when the green flag is clicked. And what I want it to do is at the very beginning, just like with the let me start that again. With its position, we want to make sure that its rotation is set to 0, basically, so that it's working appropriately. So I'm going to go ahead and go to my motion, and I want to point in direction 90, which just basically means it hasn't turned at all. Okay. I want to make sure that starts there, or else it might do some weird things if I keep hitting the green button. And then now here's where things get a little bit complicated, is we want it to rotate left and right forever, okay? So then how do we make it say like, okay, start going left, wait, and then go to the right? I'm gonna first do something on the screen, and then after that you don't need to do on your computer, so just watch, and then after we'll kind of see like, okay, what do we have to do to get this to work? So the first thing is I want it to turn 15 degrees. Hang on. Let me actually do it on the right screen. Okay, turn 15 degrees. And then I want it to turn 15 degrees back. So if I just start with this right now, nothing's happening. Okay, and that's because I'm not telling the program to actually wait between these rotations. So what I want to do is I want to, in the events section, there is going to be a wait. Or in the control, sorry, it's the same color, there is this wait 1 second. So what I want to do is I want to say, hey, turn 15 degrees. Come on, break apart, you can do it. Wait 1 second, and then turn another 15 degrees. And then now, when I go ahead and run this, it's going to go one way, and then it's going to go the other way, right? So then we saw that little bit of a turn. But I want to keep it going forever, right? So how do I get it to go forever? Is that in the control section, there's this nice forever block. This forever block looks like a Pac-Man, right? And the reason why it looks like that Pac-Man is because anything that I put in Pac-Man's mouth will then continue to repeat over and over and over again. So once again, just finish watching what I'm doing on my screen, and then you can go ahead and do it. I'm going to now click and drag my code block into Forever Pac-Man. And now Forever Pac-Man, if I go ahead and put it inside, then this is going to run. It's doing something weird. What could be wrong? Why is it glitching? Okay, so there's something about it not stopping. How many waits do I have? 1. How many actions am I doing? 2. So I should probably have another wait after the second action. Okay, so then I'm going to go ahead and put in that 1 additional wait here. Right, and then try it again. And now it's doing the rotation like I'm looking at, okay? So for this particular section, right, learning the wait block and then learning the forever block. Okay, so now I'm gonna have this on the screen. Go ahead and try it on your letters. Also, feel free to experiment with if you want it to rotate more. If you want it to maybe rotate to the center and then rotate to the other side, you can tinker a little bit as well while you're doing this. And then, of course, once you're happy with one letter, please do it for your other letters.
Can you copy that block and move it to another letter?
Oh, good. I was hoping someone would ask. So I do believe Control C. No, no, Control C, Control V doesn't work. Oh, there is. I know there's a way. I'm being, no, sad panda. Yeah, I thought Control C, Control V worked. It does?
Okay, that worked that time.
You right
There we go.
you just
Control C, Control V.
right click on your mouse and it says duplicate.
Well, the duplicate will duplicate it on the screen. And then can I then go? Yeah.
Mine worked though, so
Okay.
I don't know what is different.
Okay, so when I tested it, Control C, Control V was what was working. Yeah, so Control C, Control V. Okay. Control V, I know that's super intuitive for students. Okay, Control C, Control V seems to work. That's a good question. And then yeah. If you look up on my screen, if you just right click in the editor, then there's an undo. Okay? Okay.
So whatever you do is a separate thing, it has to be.
There's a quiz at the end of this session. No, just
They pick up way faster than we do. I know, I had Deb like teach me and stuff. But I don't understand why, sorry, I don't know where it went. Point in direction 90. I don't understand why it's a 90 and not like a 0.
And not 0. That's the way that the editor just says that it's its normal position. I totally get it. I wish it said 0.
Okay.
I'm just thinking that like 90 is this. Is that what it means?
No, so 90 is just like the I can see what you're saying. Like if we're using Cartesian plane, I don't have a really good explanation. This is unfortunately sometimes with programming language too. It'll be like, why is the default number this? And I'm like, I don't know. That's what the developers decided. So. Okay, so it looks like we're doing well. Can we move on to the next step, which is putting a backdrop in? Oh, sure.
You even have a long, complex name, so there you go. That's good, because then I can practice it 7 times.
Okay. This is actually strategically why I wanted it to do with a name, right? Because then you end up practicing it a little bit. Okay. So from here, the next thing is that we want to just, like, it looks a little bland without a background. So backdrops are in the bottom right. There's that like plus image purple button. So if you go ahead and click on that, then that can choose your backdrop. So there's a bunch of options. And once again, there is a way to upload. I didn't tinker enough with uploading because I thought that'd be too much for this class. So if you want to choose a backdrop, then you can choose a backdrop, and that would go behind all of your things. Now, once you've chosen a backdrop, I also just want to point out that you can click your backdrop, and you'll have a code editing section for your backdrop as well. Okay. So that means for your backdrop, you can also make some changes to your backdrop. So what we're going to do is we're going to get it to change color every second. But once again, you can also choose other things that you can do for that. So what's the starting block that we always use? Green flag, green flag. Very good. So then we need to go to our events and get to our green flag. And then this is once again an example of the loop, just so that we have a couple examples of that. So I'm going to go back to control and use my forever loop. And from here, what I want is that there's like this nice looks, right? So I can change color effect by 25. And like this is where you have to kind of tinker with the numbers to what kind of color effects that it changes to. I also saw a couple of you tinkering with your letters, that you could change the color with your letters to. You can technically do it this way as well. And then once again, we just want that control where we want to wait a second. So it's not just like discoing at us. I mean, if you want it to disco at you, it could disco at you as well. But now that we have that there as well, we can then go ahead and run, and then we can see how our backdrop will change colors as well as our name is moving. Okay, so I think we're supposed to end by 10. Is that correct? Okay. There is still some things I want to talk about at the end, but I do want to still give like about 5 to 10 minutes for you all to just tinker. So the thing that I will say, and like this goes back to the slides. Where are my slides? Is this my slides? This is my slides. Okay, so one thing that I just want to say is that, you know, don't be afraid to make mistakes, right? So take some time, tinker, right? And then I'll come around and help out as well where needed. And I still have some things to say at the end, okay? Is that once the program is ready, you can actually like have it share. So if you can't do it because you probably don't have a login yet, but when you do have a login, you can go to your My Stuff and then see the things that you've created, and then there will be the option to share it. So that's how you all have access to it, is that you can share it. So then if you give the link to your students on Google Classroom, that's a way that you could share some of these things. But the other thing that I want to point out is that when you get to the share, you'll get like this pop-up for copy link, so you can give them that link. But there's also this copy embed. And I just want to point this out because some of you might already have some kind of Google site that you have your students access things on. Is that a fair assumption for some of you? So the other thing that I just want to point out is that on the share, there's this copy embed. If you use this copy embed, and then you go add it to your Google site, there is this embed right here. So if I paste that in, embed code, paste in the embed code, then it will put your animation on the Google site, right? So then your students, once I resize this nicely, could actually then be able to either do an animation that you've created, or like if you did create something that the students interact with, then you can easily put it on your Google site as well. So that's kind of the last thing I want to show, is that you can share. And then also, once you've shared it, you can put it onto a Google site.
Can you show us what it would look like when published?
Good question. So what I'll do is I'll just show this link, and what it will look like is you will see this box with the green flag. That's what you'll see. Okay, so a green box with the flag, and I actually think if I go back to here, this preview, this is exactly what they'll see. Okay, green box and flag. Okay, okay. So that is that last additional thing that I wanted to show. And then just finishing up our slides in our fleeting moments, you would have noticed when you started there was a pop-up for lessons, but I do also want to point out that on their webpage, educators, they have a lot of great links, right, for lessons and for different, for either teacher lessons, lesson plans, or activities for students. Great link. This Scratch cheat sheets I found online, so it's not mine, but I took a look at it, and that was also a good one that you could print out and have that as a resource for students, and it explains a lot of sections as well. So once again, both of those links on the slide deck. That is for you to use afterwards. I do have a slide for alternatives. If you're working with little ones, code.org is my best recommendation. Hashtag not sponsored, but they definitely have things from all ages. They have a section from K to 5, and they will even separate that for pre-reading and reading. And the pre-reading section, it will actually it has simple instructions, but it also has like play, and it will read the instructions, as well as that code.org, as well as Scratch, work wonderfully on iPads. So if you have iPads and they prefer the click and dragging the blocks, works really well. The code.org was the one that I got my 6-year-old to try this week as my guinea pig, and she got through about 12 of the mini lessons. And the mini lessons start really well. Like, she did it on an iPad, and like the first lesson is like tap the icon. The second lesson is drag the icon. The third lesson, drag it to a box. And then it goes to, she got to the point where she got to some adventures. So like in code.org, you'll have like these adventure puzzles and then arrow directions, and you have to like do things. And she got pretty far in that in the week that I gave her to tinker. Warrior.js is completely text-based with JavaScript. I would say if you have really high flyers that already know some JavaScript or they want to try text-based programming, this one is one that's also free. Both of these are free. I would never send you to paid things, right? So both of them are free. Warrior.js is one that I would say has a much higher learning curve. So only for the students that are like, yeah, I already like code and like JavaScript, or I already do Python, right? That's something that they could explore with. It is text-based, where like you write the code and then you see what happens to your warrior as you're slaying imaginary snakes and defeating towers. Okay, so those are a couple additional options. Sorry, what's my time? Oh no, shameless plug. Google Classroom, if you need support, I did write a technical manual on it. So if you do want to, it's like $30 on Amazon. So if you are interested, you can always grab something like that. Totally shameless plug. And apart from that, credits for where I got the slide template. Show. Thank you so much for being here. Okay. Anyway, I have a session in 20 minutes just next door where we talk about all of the things in the curriculum. If you're interested in coming to see that, then that is going to be next door. This is the perspective, of course, like someone who doesn't teach elementary, so I totally get that, but I'm doing my best to bring in the computing science perspective into how I interpreted the curriculum at all of your levels. So that's everything from me. Enjoy the rest of TeachersCon. Thank you so much for coming here. I don't know if there's like a feedback form thing, but feedback is always great as well. Thank you so much.